Hello, everyone. I want to thank you all for joining in to this webinar. Today, we have an interesting topic about Open RAN intelligence. We have a couple people watching us on Facebook Live, on YouTube Live. I want to thank you all for joining in. I want to give a brief presentation to our host today. Is Jitendra Sati. He will be presenting about Open RAN intelligence. I want to thank you all again for joining in. And if you guys have any questions, please let us know on the chat here on the webinar. Also, you can send us an email with your questions. And with no further ado, Jitendra, the audience is all yours.
Thank you, Gabriel, and thank you. Good morning, everyone, for joining the webinar. So let me share my screen. So in the last webinar that we had, we discussed about the Open RAN basic architecture, in which we came to know that what are the different elements of the Open RAN, like the what are the centralized unit, what is the distributed unit, what is basically disaggregation. So through this webinar we will discuss about the brain of the Open RAN, that is called a RAN intelligent controller, or the RIC. So basically, RAN intelligent controller (RIC) is a main functionality software component of this total Open RAN ecosystem. It basically plays a pivotal role when Open RAN needs to deploy end to end. So Open RAN is not only a controller basically, but it's a open software platform which controls everything in the Open RAN ecosystems. So this Open RAN is being developed by multiple vendor. So hence, therefore, the RIC, or the RAN intelligent controller, is also being developed by different kind of vendors around the world. And this RAN intelligent controller basically divided into the two part. Those are known as the known real-time RIC, or known RT-RIC, and the next one is known as the near real-time RIC. So what does it mean by known real-time RIC? So basically, all those use cases, or the applications which doesn't require the tight latency coupled into the system, or the use cases which doesn't require the high latency, then those applications are supported by the known real-time RIC. However, the applications which requires high latency, or the tightly coupled latency, all those applications are supported by the near real-time RIC. There are different kind of apps which are supported by these real-time RIC and the known real-time RIC. These apps are known as the X apps and the R apps. So X app basically are the microservices which are hosted in the near real-time RIC, and the R apps basically hosted in the non-real-time RIC. So here we know that the near real-time RIC basically it's provide uh, a control which is basically based on different algorithms which are powered by artificial intelligence, and which are powered by machine learning algorithms as well. So these algorithms basically works in a controlled way manner, and provides the latency of about 10 millisecond to 1 second. So that is a more kind of good achievement when we talk about the 5G ecosystem. The next is the no real-time RIC. So basically, no real-time RIC once again provides a feedback system to the near real-time RIC via A1 interface. So all those services which are hosted at the no real-time RIC calculates input, and based on that input, it calculates certain output, and that certain output is being provided to the near real-time RIC by A1 interface. So that this is how the whole ecosystem of no real-time RIC and the near real-time RIC works. In the previous slide, we saw that there are two kinds of apps which are supported by this near real-time RIC and the real-time RIC. So those apps are basically known or basically governed or named by three ORAN Alliance group as the X apps and the R apps. So X apps are basically hosted in the near real-time RIC. You can see here near real-time RIC. So all those apps are here. X apps are here, basically hosted here, and the other apps which are known as the R apps, basically those apps are hosted here in the known real-time RIC. And this known real-time RIC are part of this total SMO that is known as the service management and orchestration. So these what are basically these apps? I mean, here can be the question like what are basically these apps? So these apps are nothing but a different kind of microservices, and microservices like I mean if you talk about the RF radio frequency perspective or the RF perspective, then there can be multiple microservices. For an example, let's say if you just want to have LT interfrequency handover, so that is a one kind of service that is called a microservice when we talk about the Open RAN. And in a similar way, you can have a multiple of these microservices, like for the mobility, for the parameter tuning, and for there are so many microservices. For an example, here you can see that these are couple of services which comes under the category of X apps, and the R apps, right? So these are all kind of microservices which are being handled by these near real-time RIC and the non-real-time RIC. So you can see here like massive MIMO beaming optimization. This is one of the most important microservice for the 5G optimization. You can see here that QoS based resource optimization, so that you can have a real-time traffic and capacity monitoring. You can you can also have a microservice of RAN slice service assurance. So this is once again an important microservice or important app for the 5G optimization, where you can have a live monitoring for every slice where the operator is going to provide to the end user or to the business entity. So these are kind of the services or the microservices which are available right now and which are part of the XApps and the RApps, and which are supported by the no real-time RIC and the real-time RIC. These XApps and RApps are basically being developed by different software communities. Like for an example, there are different startups which are globally placed. Some are in USA, some are in India, some are in Latin America as well. So those startups are developing some kind of XApps and the RApps or the microservices in order to make the Open RAN development faster. So this is how what are those accepts and the RFs, and what is their basic functionality. Here we can see that the RAN intelligent controller, basically RAN intelligent controller or the RIC basically provides three kind of use cases. So those use cases, if we look at the right side, first one is the network intelligence. So what does it mean, network intelligence? So network intelligence means that it is provided some kind of models which are already calculative or already based on some kind of input. So it already had the models on which it provides the outputs, and and those output are basically self-sufficient in order to provide the more intelligent network optimization. So for an example, like policy enforcement and the handover optimization. So let's talk about the handover optimization. So for the handover optimization, the known real-time RIC calculates or take the inputs. Let's say one handover events generate at one particular time, right? Then the known real-time RIC will capture that moment and along with all kind of its data, like how much latency it took to perform this handover, what were the input frequency, I mean, what were the frequency on which this handover occurs, right? And there can be multiple things, are parameters and the configuration parameters comes into the picture. So that known the near non-real time RIC will capture all those information and will provide that information as a model which is based on the artificial intelligence and the machine learning algorithms, and this will provide this all this information will be feeded to the near real time RIC. So in the next time, if let's say if the same handover events occur, then the near real time RIC can take that decision in a more fast and the efficient manner. So that is how the network intelligence use cases uh, this RAN intelligent controller provides. Right. The next part is the resource assurance. So resource assurance is of course the basic need for any system. So whether it's a LTE system, whether it's 2G, 3G, or the 5G. So as long as you have a good resources availability in the network, for an example, you have a pretty and sufficient availability of the physical resource block, you have a good availability of the power when you talk about the 3G, and when you have a good availability of the TRX when you talk about the 2G. So all these intelligent resource assurance can be provided by this RAN intelligent controller. The next part is a resource control. Right. So how the different sectors which are co-located for a particular technology, or which are placed in a manner or in a distance. So how the load balancing will occur across those sectors or among those sectors will be done by this smart or intelligently based applications which are supported by this RAN intelligent controller. So all these kind of use cases are provided by this RAN intelligent controller. And all these use cases are once again based on the algorithms of artificial intelligence and machine learning. So there are a lot of vendors once again which are working on these areas as well in the like for the artificial intelligence and for the machine learning. However, the Open RAN and this artificial intelligence and machine learning based algorithms for the different microservices are still in development phase. So there is a huge opportunity for any organization or for any vendor or for any individual to grow into these areas. So in this slide, I try to show like who were the who are the basic working force towards the deployment of the RAN intelligent controller or the RIC. So we know that the Open RAN is a concept which is being developed or which is being uh, concept which is generalized by the organizations like the 3GPP, the Open RAN Alliance or the ORAN Alliance, the Telecom Infra Project or the TIP, which is basically headed by the Facebook and the ISMAL Cell Forum. the Open Network Foundation or ONF, and the Open Air Interface Software Alliance. So these are the couple of entities which basically brings the concept of Open RAN, and which basically are the brain behind the development of the complete Open RAN ecosystems. So these different alliances or the organizations or the groups are working in the development of different areas of the Open RAN. Some are working in the open source software development. Some are working in the test and integration. Like there can be multiple things involved. Like as we know that Open RAN can support a softwares and the hardwares which will be supplied by the different entities or the organizations. So some organizations are working in order to provide the end-to-end integration for this complete ecosystem. Some are working on the standard development, so that all these vendors which are working towards the hardware and the software deployment can come to a certain point, and and can focus on those points to provide the flexibility and to make this Open RAN as a success. Okay, so basically the RAN intelligent controller or the RIC basically is being developed by work group 2 and the work group 3, right? So these are the two groups, like the work group 2 and the work group 3, which are basically working in the development of the Open RAN RIC or the RAN Intelligent Controller RIC. So work group 2 is basically working on the non-real-time RIC and the A1 interface, and the work group 3 is basically working on the near real-time RIC and the E2 interface, right? And here we can see that there are different working groups, like the working group 1, which is basically working on the Open RAN use cases and its overall architecture finalization, right? In the similar way, there is a working group 4, which is basically working on the open print all interfaces, right? Working group 5 is working on the open F1, W1, E1, X2, XN interfaces. So here in the 5G, there are certain interfaces like the A1, this one, the A1 and the E2. These are the interfaces which are basically newly introduced by the Open RAN Alliance. These interfaces were not there by the 3GPP definition of the Open RAN, right? However, these interfaces are introduced by the Open RAN Alliance in order to make the Open RAN system work, right? And the working group 6, or this is working on the cloudification and the orchestration. So cloudifications means, like the Open RAN will once again will be hosted in the cloud, and all those applications which we talk about, like it's whether it's a centralized unit, whether it's a distributed unit, whether it's RIC or an intelligent controller, all will be based on the virtual machines, right? So how those virtual machines will behave and how they will orchestrate in order to support the different use cases. I mean, all those things are being discussed under the umbrella of working group 6, right? Working group 7 is working on a white box hardware. So it's basically working on the disaggregation of a G node B, like how the CUs, centralized unit, and the DUs, or the distributed unit, and the RUs, remote units, will interact with each other. Working group 8 is basically working on the protocol side. So how the different protocols will behave at different layers, what are the different necessities of those protocols. So all those things are comes under the group of working group 8. And the working group 9 is working on the X haul inter transport. So this is basically working on all kind of, whether it's a front haul transport, whether it's a back haul, or whether it's a mid haul transport. So all those transport medias specifications, standards towards those transport medias are being discussed under the group of working group 9. Now, basically, here can be the question like, since we now know that what is RAN intelligent controller, how it's come into the picture, then there can be a question like, what was the need to introduce the RAN intelligent controller in this whole ecosystem? So we know that, in the when we talk about the traditional RAN systems, we know that there are different things which are based on the traditional way. So for an example, if you talk about the 2G or 3G, and if you are being an RF engineer doing the neighbor analysis, then you need to take a different inputs for the in order to perform the neighbor analysis, right? Whether it's an interfrequency neighbor or intrafrequency neighbor, you need to take a different inputs from the OSS, and based on that input you will ascertain or justify that this neighbors required to add or this neighbors to require to delete, right? And like, in this similar way you have a 3G, so where in the 3G and the 4G as well, so you have to, manually and carefully do a lot of things, right? So whether it's neighbor optimization, whether it's parameter optimization, whether it's parameter configurations checking, whether it's alarms checking or different latency checking or troubleshooting for any kind of issues, all those tasks become cumbersome when you have a traditional methods, or when you have a manual way of optimization. So since all those traditional methods took a lot of time, like I mean, when you have with those traditional methods, you have to put a lot of man hours, right? So that's why the organizations like Cisco and and other organization introduced the SON as well. However, that SON is still not that much capable, because that SON took some input which is based on certain kind of events, but it generally not artificially intelligent, or it's not took any input of the algorithms which are powered by the machine algorithms, right? Machine learning's kind of algorithms, right? So again, the sound system is also not that much of capable. The Open RAN will be, right? So that's why the Open RAN brings the concept of RAN intelligent controller. So RAN intelligent controller basically will took input of all those events which are already happened, and it will provide the input on based on those events, and it will, I mean, it is that much of self sufficient, and that much of self reliable, because its input is based on a different algorithms which are based on different events that have already happened in the past, right? So that's why it will provide a diff, fine grain network optimization method. Fine grain here means that it will for any event of the network optimization, whether it's neighbor optimization, whether it's parameter tuning, it will took a lot of things into the consideration before providing any output to the system. So that's why it is that much of intelligent. So and another advantage is like the smart factory and the industrial IoT. So we know that in the coming time of the 5G, we will see automation in the case of smart factories, and we will see industrial IoTs as well. So all those applications will be easily supported if the operator goes for their network deployment by the Open RAN, right? So we will, in the future we will see the connected cars, which is which is basically comes in under the category of 3GPP use cases for the 5G as a URLLC, or ultra reliable low latency communication. So all those applications like the automatic I mean the remote surgery, automatic cars, or connected cars. So all those things, or all those use cases which generally requires the high availability of the system, but the low latency, so will be comes under that category. And once again, I mean those cases are part of the Open RAN as well, right? So of course, those use cases will once again will be supported by the Open RAN as well. We will see, the lot of improvement in the methods of doing the shipping, logistic maintenance, trafficking management, tracking of the systems, right? And the asset management things are, I mean, which are generally, part of the different organizations. So whether it's a not only like a software organization or not a telecom organization, these are the general methods or the general work or ways which are happened or which are part of any organization, right? So if Open RAN will enable those organization in a more efficient manner, we will also see a lot of improvement and a lot of changes in the healthcare part as well once the Open RAN will comes into the market, right? So this is all about for the today's webinar. Like, we had discussed that what is RAN intelligent controller, what are the different parts of the RAN intelligence controller, how it evolved, and what are the different apps which are supported by the non-real-time RIC and the real-time RIC, what are the different working groups which are part of the Open RAN Alliance, what are the working groups which are working into the development of RAN intelligent controller. So this is all about for the today's webinar. If you have or if there are any questions, please do let me know so we can discuss now.
Yes, Jitendra, we have one question
Mhm.
from YouTube. It says, which are vendors developing Open Run Rec?
Open RAN, okay, Open RAN RIC, right?
RIC.
Okay, so basically, this RIC or the RAN intelligent controller is being developed by, like, in the earlier slide we had already discussed that this Open RAN RIC is being developed by working group 2 and the working group 3, right? And there are different organizations which are part of those groups. So organizations like Ericsson, Nokia, Altio Star, Ladisys Corporation, and Intel, and some other organizations or some other basically startups like the Stellite. This is Stellite is basically based in India, and there are some other organizations as well which are startups, or there are some even academics institutions are also working towards this RAN intelligent controller development.
Thank you. I have another one. How Open Run RIC will generate the jobs in the market?
Oh, of course, this is one of the important question. Like the Open RAN itself, is a broad term, and it is basically generating a lot of things for the market. So since it's basically a new concept, and the operators are eagerly looking for this Open RAN, because they are basically very much know that the Open RAN will not only bring the TCO or the total improvement in the cost for their system, but it will also bring a competition among the vendors. It will also bring a kind of things, so that the vendors will look for the different different microservices development, so that they can sell into the market, right? So I mean, if we follow all these things, then we can know that there are different opportunities available in the areas of software development, in the area of artificial intelligence, in the area of machine learning algorithms. So of course, there are several startups which are basically working on the microservices apps development. Like in the slides we had discussed that the RIC support the X apps and the R apps. So those kind of apps are being developed by the different startups, right? So of course, the open RAN will bring a lot of opportunities to the newcomers or to the new startups and also the individuals as well.
All right. Well, we don't have more questions. I want to thank you all. Jitendra, I want to thank you, Jitendra, for your presentation. Also, if anyone has any more questions about the presentation, please let us know by email. Well, thank you. Thank you, Jitendra. I will see you in the next webinar.
Okay, thank you, Gabriel, and thank you, everyone. Bye bye.
Thank you. Have a nice day.
You too. Thank you. Bye.